All right, so what we're working on today is working with compound and inequalities, solving and graphing. There's two words that we really need to know, and the first one is and. Whenever you have and, that is something called a intersection. And what happens with an intersection, you'll have one graph going one way, the other graph going the other way. The area that is your answer is this region here because both answers are here in this region. So that would be the and part, that's the intersection part. So with and problems, you have to graph where the intersection is, where they overlap. Okay, so let's graph this first one on the left. Let's start off by just drawing a number line, put 0 in the middle, our negative number, and then our positive number. And what happens is I'll do two different colors so you can kind of see what happens. At 2, I would have an open circle going to the right. And at 3, using a different color, I'm going to have an open circle going to the left because it's less than. Your answer area is this area where they're both shaded. So what you do for this is if I were to draw it nicely, I'd have the 0, -2, and 3. And it'd be open circles, and the overlap is right here in between. And so that's the intersection. Over here, the same one, it does the same thing. It says the same thing. What you could do is if you wanted to, you can write it down as -5 is less than x, and x is less than 1. And what happens is I have a -5, and it says x is greater than -5, so it's a closed circle going to the right. And then at 1, I have a closed circle going to the left. And again, it's your overlap section, which is right here. And so if I were just to graph this, I would use -5, closed circle, 1, closed circle, and have them come together. Now, if the two overlaps, and problems do not overlap, then it's a no solution. So this is when and does not overlap. An example would be x is greater than 3 and x is less than or equal to 1. If I were to graph this, at 3, it's an open circle going to the right. At 1, it's a closed circle going to the left. There's nowhere that I can graph both of these on top of each other. And since they don't overlap, it's a no solution. So that's an example of what a no solution looks like. The next type of problem we have is OR problems. And OR problems, these are called your unions. And what happens, it's anywhere you see an arrow, anywhere with arrow. So there's usually people say ands come together, unions go one way or the other, okay? So let's graph this to see what happens. I start with my 2, my -1. Let's get some different colors. So at 2, it's an open circle and it goes to the right. And at -1, it's a closed circle and it goes to the left. Now, if this was an intersection, an and problem, it'd be a no solution. But or is anywhere I see an answer, it works. So my answer is over here on this side, or it's over here on this side. All right, let's do another one. And I think I actually messed up. Let's make this a less than. So I know that I wrote that one wrong on the typo on the notes. So let's fix that. All right, so let's have this here. I have a 0 and a -2. My first one, we'll start with gray. At -2, it's closed circle going to the left. And in my next one, at 0, it's an open circle going to the left. Now, for unions, the OR problems, your answer is anywhere you see it. So I see an arrow here going this way, but I also see an arrow here. So your answer is actually wherever you see an arrow. And so my answer would be starting at 0, open circle to the left, because it's anywhere I see an arrow. All right, when we have OR problems, that's when you can have infinite solutions, and that is going to be when the OR problems, the arrows face each other. So if I have an arrow going this way and then an arrow going this way, they keep going in both directions. So if I have something like x is greater than -2 or x is less than 1, what happens here is at -2, it's an open circle going to the right. At 1, it's a closed circle going to the left. But I have, oh, hold on. But I have arrows everywhere. I have an arrow going all the way there and one all the way there. So they don't stop. So that's why whenever you have OR problems and they face each other, then these are all reals. All right, so let's talk about solving problems. What you need to do is you actually physically, you kind of just cover it up. Let's see. So I'm just going to cover it up and I'm going to not look at it. If I could fill it in. No, we're going to not worry about that. So you just kind of cover it up and I'm going to focus this first one on this problem. So when I solve this, I draw my line down and I have to get rid of my +6 by minusing 6. And then I have my 5x is greater than -10. And to get rid of a times 5, I divide by 5. So it's x is greater than -2. There's the first answer. Now I need to do the other answer over here. And so again, I draw my line down. Oops. Draw my line down. And to get rid of a -3, I add 3. And then bring down my 8. And I divide by 2 and I get 8. Or not 8, but 4. And so I have -2 and +4. At -2, it's an open circle. At +4, it's a closed circle. This is an and, so they should come together. And if you notice, the 2 goes to the right and the 4 goes to the left. So this is your intersection. For number 2, what I'd like us to do is let's just draw lines down. And we could take care of this all at once. The things that I'm going to have to get rid of, I'm going to have to get rid of the 3 and the 9. And I treat it just like a regular equation. And for a regular equation, I always get get rid of what's adding or subtracting first. So I'm going to subtract 9. The difference is here, I have 3 sections that I need to do it to. So I'm going to -9 on all 3 sides. So now a -6 and a -9 is a -15. 3x and 15. And this says 3 times x. So to get rid of a times, I divide. So I get -5 and 5. So this problem here, this is an and problem. And so it should look like a dumbbell where they come together, -5 and +5. I have a closed circle at negative, an open circle at positive, and they do go together. All right, when you deal with OR problems, it's similar to AND problems because you're going to just do one at a time. So let's look at this one. So I'm going to draw my line down to get rid of a plus 6 and a minus 6. So 2x is greater than 4. And to get rid of a times 2, I'm going to divide by 2, so x is greater than 2. So there's the first answer. And then it's an OR, so now I need to do this one. I'm going to minus 6 on both sides, and I get negative 5x is greater than 20, and I divide by 5. Now remember, I just divided by a negative, so I need to flip my inequality. So there's my second answer. So my answer is x is greater than 2, or x is less than negative 4. And so this is an OR, so a union, so it goes one way or the other. All right, last one, number 4, same thing. I'm going to do one at a time. I'm going to minus 6 on both sides, and I'm going to get 2x is greater than negative 8. Divide by 2. Now, I get a negative answer, but because I divided by a positive, I don't flip. It stays the same way because I divided by a positive. I want to change colors because it's getting close over here. So for this one, I'm going to minus 5. And I get negative 3x is less than negative 6. Now I'm dividing by a negative, so I am going to flip my inequality. So what I have is I have a positive 2, and x is greater than that. But then I also have a negative 4, and x is greater than that. Whenever your inequalities go the same way for this type of problem, your answer is where they are. And I see arrows all going to the right, but if you notice, they start at 4. So my final answer for this would be, if I were to graph it, negative 4, open circle going to the right, because that includes this arrow there. So when you have these types of problems, remember that ands come together, ors go apart. That's not always the rule, but 90% of the time, that's going to be what happens. And then you solve the equations, and then you graph them. A no solution occurs when you have an and problem that does not overlap, and an all reals occur when you have an or problem and they overlap and go opposite ways.